of different orography, there is a possibility that you may not, your distance is very small, but you may get some different intensity of rainfall at this point, and you may have a different intensity of this point because of different elevation conditions and also because of other orographic conditions. So this is also like you can also use this Thyssen polygon concept for the mall service area, like it can cater the areas which are adjoining to this particular mall. It can cater all those streets or this thing. So you can use this Thyssen polygon for different applications depending upon the requirement. Then we have another analysis which is very much common, that is called as the networking analysis. In fact, this particular analysis is being used in many applications related to network topology. Now here we are, the moment I say networking analysis, I am only restricted to a line topology, wherein I should know the starting node and the ending node and what are the different impedances. So you can use this, there are different type of network like directed network or an undirected network, like you have a like natural like you water bodies and all. You can even have a road network which will be a different network. So you can have a different category of network. So there are two types of operations which are possible through networking analysis. One is optimal path finding, that is what is the optimal route from one point to another, and the second one is the network partitioning, like a network allocation, that is you can define an area which can serve a particular a point which will serve a particular area, and then you can do the trace analysis and the turntables. So network is basically a set of connecting lines. It can represent river, road, like that is natural or artificial features. So natural rivers, roads, pipelines, telecommunication. So network analysis analyze the way goods can be transported along these lines, and network analysis can be done in raster or in vector, and network can be directed, like transportation is only one direction. For example, rivers, it will flow in one direction, or it can be undirected, that is the goods can be transported in both directions. So you can apply different type of networking criteria to a line. So network analysis consists of lines and nodes. So lines have a direction, so you can see that it starts here and it will end here. It starts here, it will have end here. It starts here, it will end here. So basically, if you see, it is made of links, it is made of barriers, it is made of centers, it is made of stops, it is made of different things. So you can apply a different level of condition to a network analysis. So like optimal path, in the sense like it can be based on a least cost path, that is like you can apply a different impedance or a different resistance to a particular segment of a road. Like if you talk about traffic, there could be a certain segment of road which is attributed to very high traffic, but there could be some other segment of road which is adjoining to it, may have a very less traffic. So those type of different attribute can be given to a particular segment, and which can be used for least cost path analysis. So one could be traffic density, another could be like time, any other could be a distance. There could be n number of things which you can allocate to a particular segment. So which generates a least cost path on a network between a pair of predefined locations using both geometric and attribute data. And then the network partitioning is assigns network elements, that is what if you talk about a particular point, how many network will contribute to that point. Like suppose if you talk about a school, now school can serve only 3,000 students can take admission, so it has got certain capacity too. So I can say that I can only allow 3,000 students to my school. So that type of networking partitioning or a resource allocation is possible using a network partitioning. So optimal path finding is used to find the least cost path between an origin and a destination. So you need a cost function, like it is also called the impedance, or you can even call it a resistance. So one of the attribute in the feature attribute table, you can add a length or a travel time or speed, whatever it is. And so on the basis of that attribute, it will calculate from one point to another the least cost path. So that is one of the very good utility which is available in networking analysis. So the least cost part is the one that has the minimum value of the total cost between the two nodes. So you can see that you have a starting node and you have the ending node. So you can even follow your path from here to from this to this side, but the condition is if you change your attribute, automatically your path will change. So if this particular path is based on length, the moment I change the attribute on the basis of travel time, my optimal path will change. So the most important thing in networking analysis is the database generation. And database generation is a very Herculean task, because even if you are making a database for a very small area, you need to provide n number of attributes to that particular data, and only then you can perform this type of analysis. So this is optimal path. And then we have cost factors. One more is the cost can be defined on both lines and nodes. Like you can say that you can from point 1 from 27 to 35 it is taking 81 minutes, and from 35 to 27 it is again taking. So you can apply a same number, so that is from going and coming, you can give a same weightage. So for line, the cost can be same or different along and against the line direction. So what you can do, you can even change. Maybe while going from 27 to 30, it may take 0.81 minutes, but while going from 31 to 27, since it could be two-way or a single way, you can change this number. So all those things is possible when you have a different networking topology. So the cost on nodes is used to define the turns. So the turns also plays very important role in networking analysis. Like for instance, if you have to, if you talk about road network in India, we know that we cannot turn on a crossing or any area. You cannot turn to a right side, because it is not allowed. So in that case, you have to give negative impedance to that, because it is a restricted area. You cannot provide a positive impedance. But if you want to turn a left turn, it is easily possible, because that is under our traffic rules. So left turn you can give a positive impedance, but negative impedance will be given if you are going to a prohibited area. So that is also a thing which is possible. Here you can say that, like, going you are taking 31 minutes, but while coming back you are taking 38 minutes. So all those things you can provide as one of the attribute, and you can easily address that. So similarly here, turn also, the moment you take a turn, you can give a different value, like